In this video, we're going to explore the new feature in MPanel FEA version 19, which allows us to import a model directly from MPanel Shade Designer and do an analysis in FEA. We'll start the process with a simple hypersail that we've built in Shade Designer. You can see here we're using a regular shape and 5 meters by 5 meters, so roughly 15-16 feet in imperial, with 2 meter and 3 meter height differences, no links in the corners, and a simple 8% dip span ratio. So we calculate the model, and there is a picture of the model. So a very simple, small hypersail. And we're going to make this using shade cloth. So the first step in the process here, we can obviously save this as a normal Shade Designer file and go on and make patterns. At this point, we can actually export the model as a DXF file for FEA. Now FEA is short for finite element analysis, basically fabric analysis. So we're prompted for a file name. I'm going to call it the 5 meter hyper for FEA test. I'll just replace this one. And then the next stage, we can close Shade Designer now, and we'll open the FEA program. And the new feature now allows us in the file menu to import an MPSD model. So the first step in the process is to find the file, and we do that by clicking on this button on the right with 3 dots, and it prompts us for a file. So I'm going to select the same file we just saved in Shade Designer, click Open. Now I'm using metric units, the alternative is imperial. We are going to use cantilever posts, so posts that are above ground, fixed to the ground. We'll select the generic 100mm 4-inch pipe, a 500 diameter, so that's 500 millimeters or half a meter diameter board pier, which is a typical board pier size. We'll select basic shade cloth, a 5mm edge cable, and 8mm corner fittings. So this is the equivalent, we're calling it just generic 8mm, but this is the equivalent of an 8mm turnbuckle. And we're not going to worry about snow load. We'll just put in a 50 km/h wind speed. So having selected all of these items, we simply build the model. We're prompted immediately with a summary of all of the steps that the FEA program has taken. So these are useful assumptions. It's worthwhile, if you do have a screen capture tool, to take a picture of this. But what's useful here is we can see there's one region, which we know it's one shade sail. There's a bandwidth of 69. Ideally we want to keep this below about 150. So we're well inside that. And here's some information that has been written into the FEA file ready for analysis. So at this stage, we've got a CAD drawing open with nothing in it at all. So what's happened is we've built a model in Shade Designer, exported it from Shade Designer, and imported it directly into FEA. So the model has already been built, and we can move straight to materials. So in materials we can see the fabric that's selected is generic shade cloth, and here are the edge cables at 5mm, and then down the bottom of the list we can see 4 links that are listed as 8mm. Our poles 100mm by 6mm. So any of these things we can change manually, but let's just proceed with the default settings. The fabric pre-stress, this is reasonably conservative for a small sail. And then we go to loads, and we can see written in the text here is a 50 km/h wind, and here is the pressure for a 50 km/h wind. Provided we don't want to make any changes here, we'd simply go through and solve the model for load case 0. This is the as installed state. We're going to include the weight of the fabric, run the solver, and you can see it solves very, very quickly with a steep curve. So we'll save the results. We know we've got a good solution. Load case 1 is our 50 km/h wind. We expect this to take a bit more time and will require more iterations. So I'll just add a 0 in here and run the solver and speed it up so you don't have to wait for it to go through. Note the message we get here. And again, we save the results. Now in the results tab, we can select each of the load case from 1 through 12 and produce individual results for things like the displaced shape, gradients to check for ponding, the reactions which the engineer needs to know to design footings or fixings to buildings, the size of the steel posts, and it's useful to learn about the stresses in the membrane itself and the reserve factors that we have available. Is the fabric itself capable of dealing with the stresses, and are the cables of sufficient size to deal with the tensions? And as I said, we can plot each of these individually. So for load case 0, for example, if I plot displaced shape, I can just plot the data. I'm prompted to plot an insertion point, and there we can see the displaced shape. If I look at this in front view, this is the as-built installed shape, so there should be no difference to the model that we imported directly from Shade Designer. If, however, we plot for load case 1, where we've got a 50 km/h wind sucking the fabric upwards, and again plot the data for load case 1, looking down we can see some shape change, but if we look in front view we can see a substantial amount of deflection in the fabric vertically. A far simpler way to do this is to use what's called standard reports, and here you'll see I've got standard header and reports for load cases for a high power sail. Again, I'm prompted for an insertion point, and now you'll see we get a complete grid which has been pre-programmed as part of the settings for plot outputs, which is completely customizable. You can set this up to suit what you and your engineer require. So here we can see displaced shape for load case 0 and load case 1, and here's the information about load case 1, what pressure is applied, and then the reactions itself. So we can see we've got a maximum reaction of 4.2 kilonewtons, so about 420 kilograms, roughly 900 pounds of reaction force at the tops of the high poles here. We can also see the tension in the cable and the moment in the poles, so we can determine the actual pole size based on this. And here is the depth of the footings required for a 500 diameter board pier. We actually get a plot that we need at least 1100 millimeters or 1.1 meters, roughly 4 feet of depth to resist that overturning moment. and reserve factor for the fabric. So the fabric is quite capable. We've got a reserve factor of 10, and the same with the cable. Now a separate plot here, which I've included in my settings for HIPARs, is a plot for the what's referred to as gradient plot, and this gives us an indication of whether the sail is susceptible to water collection, also known as ponding. So let's just add another load case. So we can add as many additional load cases as we like. So we'll go to load case 2, and let's add, instead of snow, we'll add rain. And we'll use the calculator, unit conversion, a pressure from millimeters of water. Let's put in 10 millimeters of water, and we're talking in the units of pressure, kilonewtons per square meter. So we select kilonewtons per square meter here, and we can see 0.098. Copy that to the clipboard, and we'll add that to the weight. Let's go back to solving. We'll this time solve for load case 2. Run the solver. Again, it's going to take a bit of time. Obviously, we're assuming here that this is a waterproof fabric, so it will collect water. We're seeing parts of the membrane have zero stress. So go back to results, this time with load case 2 selected. We'll plot the standard plot for a HIPAR. So we're not plotting the header, we're just doing the standard plot for load case 2 for a HIPAR. And it will add that directly below the other plots that we've done. And if we look at this in an isometric view, we can now see the fabric is deflecting downwards. And then if we zoom in on the gradient plot, we can see we have these points pointing inwards. So the circle represents a drop of water or rain, and then the direction in which it will flow. And what we're looking for is when these start pointing in towards each other, we know we have a high probability of ponding. So once a small amount of water collects, then we know that this will devolve quite rapidly into most likely a failure. So there you have it, a simple method to import a model you've created in Shade Designer into the FEA for analysis, to determine the size of the poles, to estimate the size of the footings, and to check for water ponding, and also check for the capacity of the fabric is adequate to the design. Thank you for watching. For more information, please contact support@mpanel.com.